Black holes, these colossal engines of gravity, have long stirred both fear and fascination for centuries. They've eluded our deepest understanding, lurking in the farthest reaches of the cosmos as impenetrable mysteries. These strange phenomena possess a gravitational force so extreme that not even light can escape their grasp, warping the very fabric of space and time. Now, thanks to a remarkable breakthrough by the James Webb Space Telescope (JWST), scientists are getting their closest, clearest glimpse yet into these cosmic titans and their surroundings, a discovery that may completely alter how we perceive the universe. Black holes are born from cosmic death, specifically the demise of massive stars. When a giant star runs out of nuclear fuel, it can no longer resist the crushing force of gravity. It collapses inward, forming singularity, a point of seemingly infinite density enclosed by the event horizon, the invisible boundary beyond which nothing returns. Once matter, energy, or even time crosses this point, it disappears from our universe as we know it. Within the singularity, our known laws of physics break down. Space distorts into unimaginable shapes. Time stretches toward infinity and gravity becomes absolute. Here, Einstein's theory of general relativity fails and quantum mechanics, our best theory for the subatomic world, offers no solid answer. Either for decades, physicists have puzzled over what really happens inside. Although JWST wasn't originally built to explore black holes, its incredible sensitivity, especially to infrared light, enables it to peer into the earliest epochs of the universe and uncover secrets buried in the dark. In a stunning leap forward, the telescope has observed the oldest known black hole nestled inside a young galaxy formed just 570 million years after the Big Bang. This behemoth, with a mass roughly 10 million times greater than our Sun, emerged far earlier than current theories predicted. Its very existence raises profound questions. How could something so massive arise so quickly in a universe still finding its shape? Astrophysicist Rebecca Len believes this is only the beginning. She remarked, "This is just the tip of the iceberg. There should be many more out there. We are just now developing the tools to study this chapter in cosmic history." Two main ideas attempt to explain this early black hole boom. One suggests that the first stars, known as population 3 stars, were much more massive and short-lived than those we see today. These stars may have exploded as hypernovae and collapsed into black holes within a few 100 million years of the universe's birth. The second theory posits that massive clouds of primordial gas bypassed star formation altogether, collapsing straight into black holes. Either way, the process had to occur much faster than scientists ever thought possible. Using its mid-infrared instrument MIRI and near-infrared camera NARCM, JWST analyzed the light from this distant galaxy by breaking it down into its component wavelengths, much like a prism, creating a rainbow among the expected light signals. Scientists found an unusual spike, indicating energy typically given off by a black hole, though faint and far away. This signature was clear. They were observing a monster from the dawn of time, but the surprises didn't stop there. In another region of space, JWST joined forces with other observatories to re-examine what was once classified as a typical radio galaxy. Upon closer inspection, the object turned out to be a blazar, a galaxy with a supermassive black hole shooting jets of high-energy particles directly at Earth. The astonishing part, these jets had rotated an extraordinary 90 degrees. This kind of dramatic realignment is so rare that scientists are still debating its cause. Relativistic jets, narrow beams of matter traveling near the speed of light, usually blast out from a black hole's poles. That these jets could pivot so drastically may suggest a galactic merger or some mysterious gravitational interaction. Fossil remnants from old jets and new emissions near the core support the idea of a staggering shift in orientation offering new clues about black hole behavior and galactic evolution. Another game-changing revelation came, not from what black holes emit but from what may invisibly surround them in a pioneering study by the Education University of Hong Kong astronomers discovered the first indirect evidence that black holes might be cloaked in dark matter, the elusive substance thought to make up roughly 85% of the universe's total mass. By monitoring binary star systems orbiting black holes, researchers noticed an incredibly subtle slowdown in the star's orbits, about 1 millisecond per year. Standard gravitational models couldn't explain this drag, but simulations using the concept of dark matter dynamical friction matched the observations perfectly. This invisible friction hinted at dark matter exerting influence around black holes. According to lead researcher Chan Manho, this is the first study to validate the existence of dark matter near black holes using this method. Meanwhile, another study led by Oxford astrophysicist Ismael Garcia Byrne uncovered something unexpected in the chemical chaos around supermassive black holes. The JWST detected complex carbon-based molecules called polycyclic aromatic hydrocarbons, pHs swirling near black holes in 3 active galaxies: NGC 6552, NGC 7319, and NGC 7469. These molecules are usually found in peaceful star-forming regions and were assumed to be destroyed by the intense radiation of black holes. Surprisingly, while smaller charged FAs were absent, larger neutral ones had survived. Scientists suspect thick molecular clouds near the black holes might shield these molecules from destruction. This challenges previous models and forces a rethinking of how pH are used to trace star formation. It also hints that the building blocks of life might endure even in these extreme environments. Each of these findings, from the cosmic scale of black holes to the molecular details in their vicinity, adds a new chapter to our ever-expanding understanding of the universe. The JWST has proven itself not just as a telescope but as a time machine, pulling back the curtain on events that took place billions of years ago. By detecting the oldest known black hole, uncovering jet-shifting galaxies, revealing resilient complex molecules, and finding dark matter's quiet hand, JWST is doing more than just peering into the darkness. It's lighting the way. Black holes, once seen as symbols of destruction and the unknown, are now emerging as portals to deeper truths about how galaxies form, how matter behaves, and maybe even how life begins. As we continue to look into these cosmic abysses, we're not just learning about deep space, we're uncovering the story of our own origins and perhaps our future. For the first time, we're not just asking what's inside a black hole, we're starting to find out, and the answers are more breathtaking, more violent, and more awe-inspiring than we ever imagined.